morning, everyone. A very good morning to all of you, bacho. We are live. We are back on ExamDost. We are back with the ESE Officer Practice Series for Engineering Services PYQs. So I'm live in the session number 4 of Control System. Quickly, everybody join. जल्दी से सभी लोग ज्वाइन कर लीजिए बेटा. We are about to start the session number 4 for Control System. चलिए, ESE 2006. A electromechanical closed loop system has the transfer function. It is asking about the stability. S cube plus 5s square plus 4s plus s 5s plus 4. Okay, s cube s square 4s square. So s4 plus 5s cube plus 5s square plus 4s plus k. Directly we cannot apply the shortcut. It is the fourth order polynomial. So I have to go by the basic method. So s square 25 minus 4, 21 by 5, k. 84 by 5 minus 5k. So these are the coefficient. So it is stable. K must be positive. And 84 by 5 minus 5k must be positive. K less than 84 by 25. So see, between 0 and 3.36. A minimum phase system has ESE 2007. Minimum phase system has no poles or zeros. ऐसे सिंपल ही हो जाएगा ना. सही है डी. No poles or zeros in the RHP or on the j omega axis, excluding the origin. Origin पे आ सकता है, बाकी राइट हाफ में कोई भी नहीं आएगा, ना ही j omega axis पे. Now here ESE 2007 again. 0 is at s equal to 1. Pole at s equal to minus 1. So this is in right half plane. So non-minimum phase. Characteristic equation is given number of roots in the right half plane. Beta, if you want in a row, you can take a positive number constant. From here, I can take 25 common. A positive number can be taken common. Okay. So answer is 0, 0. No sign change. Means no poles in RHP. No row of zeros. No poles on imaginary axis. जब जीरो का कोई रोज नहीं आ रहा है तो इमेजिनरी एक्सिस पे भी नहीं होगा. Consider the following statement ESE 2007. Consider the following statement regarding Routh-Hurwitz criteria. Necessary and sufficient condition, yes. Relative stability can be decided by location of roots. Okay. Roots origin से जितना दूर होते हैं उतना ज्यादा सिस्टम स्टेबल है. To decide the relative stability, we must know the location of the roots. The farther the root from the origin, the more stable the system is. A stable system is a dynamic system with a bounded response to a bounded input. So it is a Peebo criteria. The output is bounded when the input is bounded. So answer is D. Now, ESE 2007. This is a good question. Open loop transfer function of a unity feedback system is k e to the power minus st. Stability depends on which of the following. Okay. Okay. So now T must be positive, K must be negative. So stability depends on both K and T. It depends on both K and T. बात समझे? K आपका क्या होना चाहिए? K must be negative, T must be positive. बट K और T दोनों ग्रेटर देन 0 दे रखे ना, रुको. K और T both are greater than 0. 1 plus K minus 1 by K. तो नेगेटिव नंबर का लॉग कैसे लेते हो? Okay. This is how you take the log. E to the power depends on K. A non-minimum phase, ESE 2007, non-minimum phase network is the one whose transfer function has zeros in the right half plane, poles in the left half. Sir, poles left half में क्यों? Because otherwise system will become unstable. Okay, system will become unstable. बेटा 1 माइनस एस टी करने से इट इज जस्ट एन अप्रोक्सीमेशन. इफ यू कैन सॉल्व बाय एग्जैक्ट इलेक्ट्रिकल दोस्त, बेटर टू सॉल्व इट एग्जैक्टली. और आकाश भाई, बेसिक इलेक्ट्रिकल के नोट्स तो शायद अब नहीं होंगे मेरे पास, और उसके बदले आप नेटवर्क की प्लेलिस्ट देख लो ना, सेम ही तो कंटेंट है. ESE 2008, poles of a system lie on imaginary axis. System is marginally stable. Which of the following system are minimum phase? Pole in RHP. Pole in RHP. It has 0 in RHP. So if a pole or a 0 lie in RHP, system is not minimum phase. In the time domain analysis of feedback control system, which of the pair is not correctly matched? Okay, not match. Underdamped minimizes nonlinearity. Dominant pole transient die out more rapidly. Far away poles. So this is not correctly matched. Dominant poles में क्या होता है? Transient last longer. Transient लंबा टिकता है dominant pole में. Transient last longer. Okay. Range of K for which it represents the unstable system. ESE 2008. तो देखो s to the power 1 is already missing. So it cannot be stable. Because for a stable system, all coefficient must be non-zero and have the same sign. सभी coefficient non-zero और same sign के आने चाहिए. And you also cannot apply the shortcut. Without all coefficient non-zero, you cannot apply the shortcut. Okay. It is unstable. For K, assume A is positive, so minus K by A. Sign change. So for any value of K, this will be unstable. Any value of K. चलिए, consider the following statement ESE 2008. When all the element in one row are 0, one pair of real roots with opposite sign in S-plane, one pair of conjugate roots on the imaginary axis, Conjugate roots forming a quadrate in S-plane. Which of the following statements are correct? So all possibilities will exist. Basically, row of 0 says poles at image location. Okay. So basically, one case is right half and left half. One case imaginary axis. So that is why all three are correct. What is this quadrate? Like this. So again, image location. So this is also correct. ESE 2009, which of the following statement is correct? So open loop pole in RHP, it is unstable. For closed loop system, form the characteristic equation. Now this is a second order. You do not need Routh criteria. For k greater than 1, all coefficient are positive, it is stable. सेकेंड ऑर्डर तक राउथ क्राइटेरिया की जरूरत ही नहीं पड़ती. If all coefficient have the same sign, the system will be stable. Up to second order, you have to just check the sign. Consider the following statement. Which statements are correct? For ESE 2009, a system is said to be stable if the output is bounded for any input. Bounded input, not any input. System is stable if all roots lie in the left half plane, if all roots have negative real part. A second order system is always stable for positive values of open loop gain. तो अगर gain positive रहेगा तो second order system stable रहेगा. So answer should be 2, 3, 4. 2, 3, 4. Characteristic equation of a feedback system is given by data is missing. Try the next one, beta. Nature of system in terms of stability. So beta, this is stable. This is basically critically damped. Directly I can see this is critically damped. So it is stable. Otherwise, what you can do is you can take the Laplace transform. 1 by S. Okay. S plus 1 minus 1. Okay. So pole is in left half plane. Pole is in left half plane. System is stable for all values of K given by ESE 2010. So characteristic equation so basically K between 0 and 42. Using Routh criteria, number of routes in the right half plane. So if you see, very easy questions are asked on the Routh criteria. 4 minus 3 is 1 by 2. Then this is 6. 3 by 2 minus 12. So this is negative, positive, positive. So there are two sign changes. So two poles in the RHP. दो sign change हो रहे हैं. ESE 2010. Feedback control system. So characteristic equation is 1 plus GS HS equal to 0. So S cube. Then what about S square? Minus 15 plus 3 minus 12 minus 5 minus 17. Then 3 minus 15. मैंने क्या किया अभी? नहीं 4 minus 5. ठीक है, minus 15 minus 5 minus 20 plus 3 17. 3 minus 15 plus 10s plus 20. Okay. So this will be always unstable because sign is not same. Baki, we can use Routh criteria. 7 minus 5 is 2. So plus, minus, minus, plus. There are two sign changes. So two poles in the right half plane. ठीक है? जब तक sign same नहीं है बेटा stable नहीं हो सकता. All terms having the same sign is a necessary condition for stability. Consider the following statement. Which statements are correct? Okay. ESE 2010. Poles on j omega axis will make the output amplitude neither decaying nor growing. Dominant pole occur in the form of a complex conjugate pair. जरूरी तो नहीं है हमेशा. Gain of a higher order system is adjusted so that there is a complex conjugate pole on j omega axis. नहीं. Why will you adjust the gain to make the system marginally stable? ये कह रहा है हायर ऑर्डर सिस्टम का गेन ऐसा सेट करो कि पोल इमेजिनरी पे आ जाए. नो. Presence of complex conjugate pole reduce the effect of non-linearity. Yes, it makes the system underdamped. But फिर आपको ये चूज करना पड़ेगा. This is usual, not always. That dominant pole usually in higher order system are complex conjugate pole. ESE 2010, a distinct pole always lies on the real axis. A dominant pole has a large time constant. Correct. Distinct pole तो really हो सकता है ना, because complex pole exists in conjugate pair. So answer should be A. ESE 2010, all coefficient of characteristic equation should be positive. No term should be missing. So basically, that is the necessary condition. If it is violated, system is not stable. If it is violated, my system is not stable. Characteristic equation is given. Again, beta, there are two sign changes, so it is unstable. ESE 2012. Okay, range of K for the system to be stable. ESE 2012. This is my characteristic equation. So K must be positive. Then use internal product greater than external. K less than 390. Simple question. ESE 2013. Repeated. ये क्वेश्चन हम देख चुके. ESE 2014. Number of roots in the right half. Apply Routh criteria. 2 minus 4 minus 2. Minus 8 minus 15. Minus 23. Two sign changes, so two roots in the right half plane. Characteristic equation is given for system to be stable. First of all, beta, to be stable, all terms, ESE 2015 it is, all terms must have same sign. So K must be positive and internal product greater than external product. 5K greater than 10, K greater than 2. B. Consider the following statement related to Routh-Hurwitz criteria, which is correct. ESE 2015. Okay. So it is used to determine relative stability. No. Valid for real coefficient. Yes. Applicable for only non-linear system. No. It does not provide the exact location. फिर इसका 1 to 4 दिया होगा. राउथ क्राइटेरिया पता है एब्सोल्यूट स्टेबिलिटी बताता है. रिलेटिव स्टेबिलिटी के लिए जुगाड़ करना पड़ता है. शिफ्ट j omega axis, that is imaginary axis, to left. It directly does not tell you the relative stability. It only tells you the absolute stability. निशांत भाई, कमिटमेंट मेरा है तो कमिटमेंट तुम्हारा भी तो, अगर तुम 4 साल से मेरे साथ कनेक्टेड हो. The first element of the rows of a Routh-Hurwitz criteria test showed these signs. So 1 sign change, 2 sign change, 3 sign change. 3 roots in the right half plane. Okay. Four, 3, 2, 1, 0. Basically fourth order system. So 1 root in the left half. System is unstable. 1 and 4. ESE 2015. How many roots lie in the right half plane? 2, 2, 10. 2 minus 10. Minus 40 minus 10. So there are 2 sign changes. So 2 poles lie in the right half. Number of pole of a linear control system lie in the right half. For a bounded input, the output of this system. अब एक चीज बताइए, पोल राइट हाफ में है तो बाउंडेड इनपुट के लिए आउटपुट कैसा मिलेगा, बोलिए. What kind of output you will get when the input is bounded? It could be unbounded. It could be अच्छा, none of the pole, sorry, number of pole मैंने पढ़ लिया. It none of the above. बट अगर इसके कोई भी पोल राइट हाफ में नहीं है, बट मे हैव repeated poles on imaginary axis, so we cannot comment. Simple pole on imaginary axis, simple pole माने non repeated. Marginally stable, तो कुछ भी हो सकता है बेटा. Steady state error, this is type 1 system, this is parabolic input, so order of input is greater than the type. ESE 2016, error is infinite. ESE 2016, when the K of the open loop transfer function greater than unity of order greater than 1 is varied from 0 to infinity, the closed loop system may become unstable. ठीक है. For high K system may be unstable. इसीलिए बहुत बार K का मैक्सिमम वैल्यू निकालते हैं ना स्टेबिलिटी के लिए. Most of the time we find out the maximum value of K for stability. Frequency of sustained oscillation. Now the characteristic equation is like this. So how to find the condition for sustained oscillation? So make this 0. So this equation will become so oscillation frequency is √5. What value of K will result in a steady state error of 1 degree when the input rotates at 10 RPM? Okay, 10 RPM means 10 into 360 degree by 60 degree, 60 degree per second. So RT input will be 60 T. That is a ramp input. For ramp input, I need kV. So error will be 60 by kV. So K will be, I think, 10.47. 10.47. Stability of a system deteriorates when integral control is added because integral controller adds a pole at origin. With integral control, order increases, system tends to become unstable. Yes. So A. Correct explanation. जब भी सिस्टम में पोल ऐड करते हैं ना, स्टेबिलिटी रिड्यूसेस. बाय एडिंग जीरोस द स्टेबिलिटी इंप्रूव्स. क्लोज लूप ट्रांसफर फंक्शन इज एज फॉलोज. द सिस्टम इज Internal product is 8 into 19. Check the denominator, beta. External product is 1 into 12. Internal product is greater than external product. It is stable. When the damping coefficient is -2, the system response will be -2. Roots are real and lie in right half plane. So we have exponentially increasing output. तो इसमें none of these हो जाएगा. अगर जीटा 0 से -1 के बीच में आता ना, तब आपका आंसर सी आता. This would be true for this case. Okay. So basically, if zeta is less than -1, then exponentially increasing output. बेटा जेके एसएसबी के लिए यही सीरीज फॉलो करनी है अब्दुल. इसी लेवल के क्वेश्चन जेके एसएसबी में आते हैं. जेके एसएसबी के इतने क्वेश्चन प्रीवियस ईयर के अवेलेबल नहीं है कि उसके लिए अलग से पीवाईक्यू लगा सको. एस क्यूब प्लस 17 एस स्क्वायर प्लस 60 एस प्लस के फॉर एंश्योरिंग स्टेबिलिटी. Internal product greater than external. 1020. So basically C. K is less than 1020. ESE 2018, number of roots lying in the left half and right half. Four minus 4, 0. 22 minus 10. That is 12, 6. Now take this to be epsilon greater than 0, S square. 4 epsilon minus 12 by epsilon. And 10 epsilon, 10 will be directly. S की power 0 is 10. So beta 4 epsilon minus 12 by epsilon. Since epsilon is small, therefore negative. So this term is negative. This is positive. Okay. Now what about the S to the power 1? Epsilon small है, so negative by negative, it is positive. Epsilon बहुत छोटा है तो ऊपर भी -72, नीचे -12, so it is positive. So basically 2 sign changes, 2 in the right half, 3 in the left half. Why 3 left half? Because total roots are 5. Total 5 है. ESE 2018 again. -22 minus 18, 4 by 2, 2. Now this will become 0. So this will be my auxiliary equation. So S is plus minus 3J dA by ds. So we will take 4, 18. Okay. So no sign change. No pole in RHP. 2 imaginary. Therefore 2 LHP. Total 4 है ना? ठीक है. 2 poles lie on the imaginary axis. from here s equal to plus minus 3 iota. The range of k for which the system is stable, characteristic equation is 1 plus gs equal to 0, s square 1 plus k minus 0.9s or 2k, 2s 3k actually, 3k minus 0.1 or 2k. So 1 plus k positive, 3k minus 0.9 positive, 2k minus 0.1 पॉजिटिव, या फिर सब कुछ नेगेटिव कर लो, सेम साइन होना चाहिए ना. बेसिकली k लेस देन -1, k ग्रेटर देन 0.3. दो कंडीशन हो सकती हैं. ठीक है. ESE 2019 ऑल मस्ट हैव द सेम साइन. ठीक है. ऑल मस्ट हैव द सेम साइन बट इट कैन बी पॉजिटिव और नेगेटिव. क्वेश्चन 41 में एस स्क्वायर सही है क्या? एस स्क्वायर 2, 22 माइनस 18 डिवाइडेड बाय 2, तो 2 ही तो आएगा. एंड ये 18 डायरेक्टली आ गया यहां पे, ये वाला 18. ओके. ट्राई द नेक्स्ट वन बच्चों. देखें भाई, S4 1, 23 into 6 138 minus 40 98, 49 into 40 1960, right? 1960 by 3 minus 300, 1960 by 3 minus 300, so 1060 by 3 divided by 49 by 3. So all coefficient positive, all poles lie in the left half. बेटा ये आखिरी सब्जेक्ट चल रहा है अब्दुल, सारे सब्जेक्ट हो चुके बेटा. बाउंडेड इनपुट बाउंडेड आउटपुट स्टेबिलिटी इंप्लाइज एसिम्प्टोटिक स्टेबिलिटी फॉर बीबो स्टेबिलिटी से आप कह सकते हो एसिम्प्टोटिक स्टेबिलिटी भी इंप्लाइड होती है. किसके लिए? फॉर कंट्रोलेबल एंड ऑब्जर्वेबल सिस्टम. व्हाट इज एसिम्प्टोटिक स्टेबिलिटी? That HT impulse response tends to 0 as t tends to infinity. ht 0 जाएगा as t tends to infinity. Which of the following ESE 21 is a powerful frequency domain method for extracting information regarding stability as well as relative stability? Nyquist criteria. Others are time domain approach. Root locus and route criteria are time domain. Nyquist is frequency domain. Consider the following statement related to the stability. Exponentially decaying? No. Exponentially growing if pole are in right half. Pole of multiplicity greater than 1 on imaginary, system is marginally stable. Unstable. Multiplicity greater than 1 mane repeated pole. Repeated pole on imaginary make the system unstable. If one pole is present in RHP, system is unstable. A system is stable if the natural response approaches 0 as t tends to infinity. This is your asymptotic stability. That natural response must be 0 as t tends to infinity. D. ESE 21. Again, minimum phase transfer function. Zeros in the right half, poles in the left half. This I already solved for you. For the closed loop transfer function as a necessary condition for stability, characteristic equation must have real roots must be negative. No nil solution. सॉल्यूशन तो कुछ ना कुछ आना ही चाहिए, तो 1 and 3 होगा यार. जस्ट अ मिनट बेटा. सिस्टम ज्यादा हैंग कर रहा है आज. Just a minute, let me restart the system. भाई कब अनस्टेबल और स्टेबल आएगा ये? तो बेसिकली ऑल कोएफिशिएंट मस्ट बी पॉजिटिव, सो k लेस देन 8 एंड k ग्रेटर देन -1. तो -1 to 8 it is stable. So outside this range unstable. 6 is inside stable. 12 and 15 are outside unstable. ESE 24. We have to apply Routh-Hurwitz criteria. 8 minus 6, 2. 4 minus 5 minus 1. So 6 minus 2, 8. Minus 8 minus 5 minus 13. 2 sign changes unstable. Again ESE 24. The system is stable for this is second order. All coefficient positive. Okay. So stable. K plus 2 is negative and 2k plus 1 is positive. या तो ये 5 होगा. ए सेकेंड ऑर्डर में इतना काफी होता है. चलिए नाउ वी कम टू रूट लोकस. द नंबर ऑफ सेपरेट लोकाई और पोल ऑफ द क्लोज लूप सिस्टम is 3. Separate loci is maximum of pole, 0. There are 3 poles and 1 zeros. So separate root loci is 3. सर मैंने ऑलमोस्ट सभी सब्जेक्ट पढ़े हैं JKSB के लिए, मत मुझे रिवीजन करना नहीं आता. रिवीजन में बेटा नोट्स रिवाइज कर लो और ये वाली सीरीज कंप्लीट कर लो. Number of root loci is equal to number of poles if the latter is more than the number of finite zero. ठीक है, तो बेसिकली ये कह रहा है अगर P ग्रेटर देन Z होगा तो रूट लोकाई इज एक्चुअली इक्वल टू P. करेक्ट. The characteristic equation ESE 2001 is given like this. Asymptote meet at a point. So beta, first of all you have to convert it to a GSHS format. So take the k terms separately. K वाली terms को separately लो and divide by rest of the function. बाकी के function से divide कर दो. So GSHS is so asymptote meet at a point called centroid. Summation of pole minus zeros. So C minus 2, 0. Which of the following are characteristic of the root locus? There are 2 pole, 1 0. So P minus Z is 1. It has 1 asymptote. Okay. So for imaginary axis intersection, वी हैव टू गो बाय राउथ, है ना। इमेजिनरी एक्सिस इंटरसेक्शन के लिए राउथ से जाते हैं। s टू द पावर 1 कोएफिशिएंट इज 0, तो नेगेटिव k तो लेंगे नहीं, तो नो। टू रियल एक्सिस इंटरसेक्शन, तो बेसिकली टू रियल एक्सिस इंटरसेक्शन, ब्रेक अवे एंड ब्रेक इन। टू जीरोस एट इंफिनिटी नहीं, 1 0 एट इंफिनिटी। वाई? बिकॉज p माइनस z इज 1। तो पोल्स आर वन मोर देन द जीरो। पोल आपके जीरो से एक ज्यादा हैं, तो टू बैलेंस द पोल 1 0 will lie at infinity. And let me explain the point number 3. For point number 3, basically this is the situation. So there will be a intersection with the real axis like this. So break away and break in point. ठीक है? तो आंसर क्या है? 1 and 3, D. Next, correct root locus referring to poles and zeros at चलो ये ले लो, J5 and J10. तो बेटा वी हैव टू कैलकुलेट एंगल ऑफ डिपार्चर। अगर करेक्ट रूट लोकस जानना है ना, तो एंगल ऑफ डिपार्चर निकालना पड़ेगा एट योर कॉम्प्लेक्स पोल। ओके, so I'll connect it with the pole. I'll connect it with the 0. -90, 90, -90. So basically 90 minus 90. So it is -90. The angle of departure is basically 90 degree. So if it is 90 degree na, the branch will go like this. अगर 90 degree है तो branch will go like this. Okay, so answer should be अब यार इसमें तो कुछ भी नहीं बन पाएगा। चलो, नन ऑफ दीज हो जाएगा फिर। ओके, क्योंकि यहाँ पे पोल अपने को नीचे दिख रहे हैं ना बेटा, यहाँ पे पोल ऊपर दिखा रखा है। इन सी एंड डी दे हैव शोन पोल अबव द जीरो, सो आइदर द लोकेशन ऑफ पोल मस्ट चेंज। Consider the following statement with reference to the root loci of the characteristic equation of unity feedback system. Okay. So there are 3 zeros, there are 2 poles. So it starts at a pole, ends at a 0. So this is wrong. Starts at a open loop pole or infinity, ends at a 0. There are 3 separate root loci. Yes, because it is maximum of P comma Z. सर पोल या इंफिनिटी से क्यों स्टार्ट कर रहा है? देखिए, zeros is greater than pole, therefore to balance zeros, one pole lies at infinity. So therefore it can start at infinity. ये इंफिनिटी से भी स्टार्ट कर सकता है, खत्म ये जीरो पे होगा. तो बेसिकली 2 and 4, 2 and 3 आएगा ये. 2 and 3 नंबरिंग गलत हुई भी है. Number of root loci terminating at infinity. Poles are 2, zeros are 3. So 1 root loci actually originates at infinity, not terminates. So answer should be 0. 0 पे कोई खत्म तो होगा नहीं, शुरू होगा एक 0 से क्योंकि पोल कम पड़ रहे हैं. तो 1 pole will lie at infinity. Okay, control system breakaway point. Roots will be like this. So beta, the locus is like this. So basically there are 3 breakpoint. The 2 are complex and 1 is real. This is 1, 2, 3. तो ये इसका रूट लोकस बनता है 3 ब्रेक पॉइंट, 2 कॉम्प्लेक्स, 1 रियल. ओके. An addition of a real zero results in increase of stability margin. Yes, it improves stability. Addition of pole reduces stability. Addition of zero improves stability. It will bend the root locus to the left. रूट लोकस लेफ्ट में जाने का मतलब है पोल्स ऑफ द क्लोज लूप ट्रांसफर फंक्शन शिफ्ट लेफ्ट, दैट इज अवे फ्रॉम ओरिजिन, so it is more stable. Angle of asymptote. So collect the k terms, divide by rest of the expression. So poles are 4, zeros are 1, p minus z is 3. So angle is 60, 180, 300. Simple. ये तो standard angle. Next, open loop transfer function has m pole n zeros. M is greater than n. Since m is greater than n, separate root loci are m. Separate root loci n, no. Approaching infinity, yes, m minus n. ESE 2005, 1 and 3. Open loop transfer function for a unity feedback. So this is a pole, this is a pole, this is a zero, and one branch is going to infinity. एक -5 पे खत्म हो रही है, एक infinity पे जा रही है. So this should be the result. Branches always originate at open loop pole and terminate at 0. Addition of a pole reduces stability. Okay, reduces stability. Rise time increases, bandwidth reduces. सिस्टम स्पीड रिड्यूसेस। जब भी आप पोल ऐड करते हो ना तो स्पीड घटती है। ESE 2007 addition of a pole shifts the root locus to the right. Yes. Stability reduces. अगर राइट जा रहा है तो रिड्यूस होगी। If number of poles increase, angle of asymptote. If the number of poles increase, angle of asymptote for complex pole is reduced. So angle of asymptote reduces. B. क्योंकि देखो अगर P बढ़ेगा तो P माइनस Z बढ़ेगा, तो एंगल 2P plus 1 pi by P minus Z, तो angle will decrease because P minus Z increases. ESE 2007 root loci can be used for analyzing stability and transient performance. Transient कैसे? Zeta and omega n can be computed. ग्राफ से जीटा और ओमेगा एन निकाल सकते हो। Insight to the system stability performance, yes. Shape of the root locus gives the idea to the type of controller, yes. क्योंकि आपको परफॉर्मेंस पता है, you know if the overshoot is high, you know if the rise time is high, you can decide controller, but it cannot handle more than one variable at a time. So it can only handle one variable at a time. So D is incorrect. Based on root locus, intersection of asymptote must always be on real axis, centroid. Centroid is always on real axis. Asymptote of root loci refer to the angle when k is 0, no. As k tends to infinity, branches become parallel to asymptote. So one only. Infinity पे branches asymptote के along जाती हैं. ESE 2008 K can be determined as product of length. This is the graphical method of finding K. Product of length from pole, product of length from zeros. Okay, C. Correct effect of adding a zero. Relative stability increases. By adding zero, you can increase stability. Coordinates of the center of the circle. Okay. When GSHS is like this, so center lies at minus B comma 0. And radius root B square minus AB. Number of asymptote and centroid. P is 4, Z is 1. So number of asymptote P minus Z is 3. Centroid, sum of the pole minus sum of the zeros divided by P minus Z. See. Sum of the pole minus sum of the zero upon P minus Z. So that's it for today, bachcho. Tomorrow there will be 2 sessions for control, 9:30 and 11:30, and day after tomorrow control will be over. तो ये लास्ट सब्जेक्ट है, कल 2 सेशन होंगे 9:30 11:30 और परसों सिर्फ 1 सेशन होगा, उसके बाद खत्म हो जाएगा. टोटल 7 सेशंस ऑफ कंट्रोल सिस्टम. ओके, so I'll see you all tomorrow at 9:30 as well as 11:30. Thank you.